visible for you, so that it can measure your correct time. So yeah, GNSS satellite have automatic clocks, and transducer, computers, and supporting equipment either in the orbit or in the Earth. So yeah, and the signal of each satellite allow the user to measure an approximate distance from the receiver and the satellites out. So yeah, and the basis of all GNSS system is that users determine its position measured by at least 4 GNSS satellites at the same time. There should be 4 satellites. So they can know your latitude, longitude, and height. And the next one is clock errors. So easy to know that. So how can we measure GNSS measurement correction? So it's like we have put this distance measurement that and we know that they are in at the same point. So every 4 satellites will end you in the same position. So then you can measure. Then you have a nice measurement.
Okay.
So the calculating the position of the satellite, knowing the exact distance from the satellite to Earth and traveling time, can be calculated easily by the satellite to the user's receipt and calculate the distance of the satellite. It will position the determined. So that means all the satellites will make the distance. Will know the exact position of the determine its location. So it's easy if you have the 4 satellites. So every satellite will can make you an exact thing. So we need 4 satellites. So you can measure the exact position X, Y, Z position of you. Yeah. So GNSS segment have 5 segments to for this function. So it's like space segment. There are a lot of satellites on the space, which is rotating around the Earth. And next one is control satellite. Control segment. It is located in the Earth, but then there will be the main work of the control segment is to control the whole system, including maintenance of system, tracking all the satellites on the orbit, and the clock parameters, monitoring the accurate data, and upload the message, and download the message, and write it down. So there are a lot of systems in the Earth to do that thing. So user segment, it's for the us, like once a passive receiver, receive it, decode it, that's all. So this is for the user segment. Yeah, determining of the signal traveling time. The first one is the signal processing from satellites. Now we code the replica. So that means we take a signal and decode it in the next form. And you know when we do this, when we get the message from the satellites, there are a lot of errors. So what are the errors? Causes of the errors. These are the errors causes the error source. And yeah, so there are a lot of what you call from the Earth. Distance between Earth.
You're from Earth.
No, and the satellite. There are a lot of what you call
interference.
Interference.
Yeah.
So these causes, like in the ionosphere and troposphere, ethosphere either. So it's like when the message comes through that thing, there are a lot of disturbance in the between.
Right.
Yeah. So ionosphere, we have the 7 meters. It means there should be plus or minus 7 meters difference. So it will cause the error. And this thing is about that thing. And yeah, this is interference caused by the reflection of the signal. So if we are in this position, the signal can go from anywhere. It's going. I can do that thing.
But it's going. Your
Yeah,
signals.
the house, the buildings, everything surrounded you can distract the signals. So you need to be you know, in the what do you call this? The free space, so that the satellites can catch you. Otherwise, if you be in the nearby buildings, they can go to the buildings and they reflect to you. So there will be a problem. So it should be a little bit, what do you call that? Far. Oh. It should not be around the what do you call that? Thing. And if you have DOP, these are the measures. How you measure those things? So we already studied this thing in last semester, right? Yeah, the fate of satellites geometry is usually expressed by geometric dilution of precision. GTOP factor. So yeah, this is so these are used to calculate the DOP value difference variation are distinguished by these values. So GDOP, and if we use GDOP, it will be like all over accuracy. It will measure 3D coordinate and time. So it will be like x, y, z plus time also. And for the PDOP position, it will measure mostly the position. So it will be like x, y, z. So it will be like latitude, longitude, and height. This thing will be. And as DOP, horizontal, it will measure horizontal accuracy. So we need to, it didn't just use two coordinates, x and y. It didn't use height. And fourth is vertical. So it will be the vertical, it's just a height. And T is time duration, just the time. Yeah, and this is for our lab, what is the practical part. So what we did is we just received the information from the satellites, right? Using the Novatel. So we'll get the information. So to know the exact position and time, we just need to click on any satellites visible over here. Just click, and you can find your PLM, azimuth, elevation angle, and status. Everything will be here, and you can find here pseudo range, and here latitude, longitude, and time. So it's height. So from that thing, we can make graphs. So here is a graph for azimuth to time, and elevation angle with time, pseudo range with time, noise ratio over time, latitude on time, longitude on time, and it will be height and time. And this is longitude over latitude. So from that graph, we find this thing. So we can know the values over here. And these are the just DOP data from all this part. Yeah, so it's just the values. And these are the Cartesian coordinate we can find by drawing the values of this thing. And this is the polar coordinate of these satellites. And yeah, that's all. So we use what do we say that? We use so yeah, GNS is used universally to identify any satellite's position and to get the nice to get the nice accuracy the data from the satellites. We use the showing data, right? What I showed you previously. So we need to use that when receiving the measurement of the active satellites. You can find PRM, azimuth, elevation, status, and latitude noise ratio appear to calculate the value of both latitude and longitude, and the relative error using mean value. So what we get from the DOP result, we can find these answers. So this is the reason that we are able to know the data from the satellites and convert them into human reading, so that everyone knows the code and respond what we need to the satellites. So yeah, that's all. Thank you.